Now let's look at differentiating the trig functions finally. You'll find these in your textbook, all of these rules. I would advise that you write those down. So you now have a long list of differentiation rules along with your exponentials, logarithmic, product rule, quotient rule, and chain rule. All of those rules will still apply with these. So make sure you have a good look, and now let's apply them. This table over here, just some properties that we came across. So sine squared theta plus cos squared theta equals 1. That's your unit circle rule. Tan theta is sine over cos. That's a handy one to know. And these are double angle formulas. You spec maths people should know these quite well. If you don't know them, that's okay. Just make sure if you recognize or see sine 2x or sine 2 theta, you are allowed to replace it with these properties. So let's get stuck in. Let's have a look at a simple function that we want to differentiate. Okay, so we've got two of these functions here. Let's just grab our pen. The first thing we can do to help us differentiate this is to simplify it first. So I'm going to rewrite this to be, this is the same as sine x to the minus 1 because it's to the 1 downstairs, and then when I put it upstairs it becomes minus 1. And this is also can be written, and we'll see that a little bit later, a different way to write things. So now I'm going to differentiate, and I'm going to use the chain rule. So the power goes out the front, so it's minus sine x. We have to take 1 from the power that's already there, and then we have to multiply it by the derivative of what's inside the bracket. So this is where we go back up and we look at our rule. So what is the derivative of sine x? What's cos x? So we just pop there times cos x, and we're done. Now I can simplify that just a little bit, just to show you a way how we write things of notation. So here, minus cos x stays upstairs because it hasn't got a negative power. And this thing here, sine x, that's going to be all squared. You will rarely see it written like this. In fact, the shortcut way is we pop the little squared right after the end there, so it's sine squared x. That is the same, it's equivalent to this. The reason we want to show that to you now is because when you see things, see like here now for the next question, we can rewrite this to be 3 cos x. We know that is now to the minus 2 because downstairs that was all squared, and now if we want to put it upstairs it becomes to the minus. And that will now be easier to differentiate. So again, we're going to apply the chain rule similar to what we just did in the example before. So the minus 2 comes out the front, times us by 3, so that's minus 6. We write the function cos x. We take away 1 from the power, but now we have to multiply it by the derivative of cos x. So we go up to our new rules. Derivative of cos x is minus sine x. So times that by minus sine x. Remember, you don't have to simplify. I'm just doing it in this case. A negative times a negative is a positive, so that becomes 6 sine x. And that is, so this will go downstairs and it's cos x all cubed, and we can write that as cos cubed x. It's just a shorthand way for writing cos x all cubed. That looks a bit cumbersome. That's a bit neater. Okay, on to the next type of function. So we've now got cos of a function. Go back up and look at our rules. I'm going to be applying this one here. So we write minus sine of the function times the derivative of what's inside. Let's apply that over here. So this becomes dy by dx equals minus sine of that function, 5 minus x squared, but then the rule said to times it by the derivative of this function here. Now the derivative of 5 is 0, derivative of minus x squared is negative 2x. Again, tempted to tidy that up. Negative times a negative is a positive, so 2x sine 5 take x squared. hopefully getting the hang of it, but please notice, keep going back and looking at your rules. It's the first time you're using them. You need to get used to them, get a bit of practice. Okay, we now come to our next one, and technically this should be sine of 2x there. And so here we've now got a function times a function. The first function being sine 2x, the second one being cos, and remember x over 4. I hope you're looking at that as it's being a quarter times x. So this means product rule, and off we go. So dy by dx. This is still a bit similar to this. This is sine of a function. So it says write this. So we're going to go back up. What happens if I've got sine of a function? Go back and look at the rules. So sine of a function, we write cos of that function and then times it by the derivative of what's inside. So that's going to be cos of the function, so cos 2x, but I times it by the derivative of 2x, which is 2, and I'm going to pop that out the front. I times it by x over 4 because I'm not differentiating. Remember, it's the product rule, so it's differentiate the first function times the second plus write the first function and times the derivative of the second function. And hopefully you remember already that the derivative of cos x is minus sine. So that's going to be times minus sine x over 4. But don't forget you have to multiply by the derivative of this, which is 1/4. That's looking a tad messy. So we'll tidy it up. 2 cos 2x. I'm not doing anything major here with the tidying. I mean, you could just leave it with the line above. And 1/4, so that'll be minus 1/4 sine 2x sine x over 4. And that's done. Okay, last one, and hopefully you're getting a hang of how we can apply the derivative rules we already know and the new ones that we've discovered today. So this one, what should we do first? Well, I think we'd like to rewrite this like we do before with all square roots. So I'm going to look at that and say, well, that will be sine 2x to the half. This will now involve the chain rule. So dy by dx. The half goes out the front. We write the function, so sine 2x, take away a 1 from the power, so it's minus a half, but then we have to multiply by the derivative of what's inside the bracket. Now remember, the derivative of sine of a function, so we say it's cos of that same function times the derivative of that, which becomes 2. So if I really wanted to tidy it up, a half times 2 cancels. This stays upstairs because it's positive, so that's cos 2x. This goes downstairs and that becomes root sine 2x. But remember, you don't actually have to simplify unless the question asks you to. All right, so hopefully this gives you a hand with how to differentiate and apply those rules. Just in case you're stuck, please make sure you complete the questions from the textbook. Good luck.